Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify compound B from the oxidation reaction. A. C8H10 is oxidized by KMnO4 to give B. C8H6O4. KMnO4 oxidize alkyl substituents on a benzene ring to carboxylic acid groups -2. C8H6O4 has molecular formula consistent with a benzene ring bearing 2 Co groups, benzenedicarboxylic acid, since C6H4, Co2 is equal to C8H6O4. This means A must be a dimethylbenzene, xylene, with 2 methyl groups being oxidized to 2 carboxyl groups. Moving on to the next step. Eliminate option A. Ethylbenzene, C8H10, upon KMnO4 oxidation gives benzoic acid, C7H6O2, not C8H6O4. So, A is eliminated. Moving on to the next step. Determine which xylene isomer gives only one product upon bromination with Br2Fe. Br2Fe is electrophilic aromatic bromination. The number of unique monobromination products depends on the symmetry of the dicarboxylic acid, B. Para-xylene, B, oxidize to terephthalic acid, benzene 1,4 dicarboxylic acid. The ring has only one unique ring position available for substitution. Positions 2, 3, 5, 6 are all equivalent in pairs. Actually, positions 2, 3 are equivalent and so are 5, 6, but by symmetry positions 2 and 3 are equivalent to each other, and position 2 is equivalent to position 3 by the mirror plane. In terephthalic acid, all 4 remaining H positions, 2, 3, 5, 6, are equivalent due to the high symmetry, D2H, so bromination gives only one product. Bromo at position 2 is equal to bromo at position 3 is equal to bromo at 5 is equal to bromo at 6. Thus only one monobromo product is formed. Metaxylene, C, oxidized to isophthalic acid, benzene 1,3 dicarboxylic acid. The remaining positions are 2, 4, 5 and 6. Position 2 between 2 Co groups is unique. Position 4 and 6 are equivalent, flanked by 1 Co. Position 5 is unique. This gives multiple distinct products, not one. Orthoxylene, D, oxidized to phthalic acid, benzene 1,2 dicarboxylic acid. Remaining positions are 3, 4, 5, 6. Positions 3 and 6 are equivalent, positions 4 and 5 are equivalent, giving two distinct monobromo products, not one. And for the final step. Confirm answer. Only para-xylene, option B, 1, 4-dimethylbenzene, satisfies all conditions. Oxidation gives C8H6O4, terephthalic acid, and bromination of terephthalic acid gives only one monobromo product, C8H5-Bro4, due to the symmetry of the para-substituted ring. Therefore, the correct answer is B. Therefore, the correct answer is option B.